Let's see another example. Using the same bone density test, find the probability that a randomly selected person has a result above -1, which is considered to be in the normal range of bone density reading. So recall from our previous example that the test result is given as a z-score, and that has a normal distribution with a mean of a 0 and a standard deviation of 1, which means it is a standard normal curve. And I told you that in order to solve a word problem in this chapter, you have to go step by step. The first step is that you have to draw a picture. You have to draw a figure and label it. The first step, draw a figure. Let me draw a standard normal curve. This is a standard normal curve. Exactly in the middle, write the mean value, which is a 0, and a standard deviation. Show the standard deviation. Now, just show 3 standard deviation on the right side and the 3 standard deviation on the left side. Just show this. This is 1, this is 2, this is 3, this is -1, this is -2, and this is -3. This is the first step. Again, I repeat, first step, draw a bell-shaped curve, indicate the mean and indicate the standard deviation. Second step, what we do in the second step? In the second step, we indicate the value of our interest. We indicate the value of our interest and shade the desired region to be computed. That's what we are going to do now. Now, what is the desired value? It's a -1. I'm going to indicate this value in this graph. So that value comes out to be -1. Let me shade that. This is the -1. This is -1. And I'm going to draw a wall like this. This is the wall I'm going to draw, -1, right? Now, by drawing this wall, my graph is divided into 2 portions, portion 1 and a portion 2. 1 and a 2. Now, why I number these portions? Because I want to make sure that you understand which portion I need to shade. Which portion I'm going to shade, it will be told to me by the problem. Find the probability that randomly selected person result has a result above -1. All the values on this side, all the values on this side are below -1, and all the values on this side are above -1. So clearly, in this case, I'm going to shade the region 2, not the region 1, as we have done in the previous example. Above -1, right? Above -1. This is the region, this is the area I have to calculate. This is the z-score I have, a -1, and this is the area I have to compute. Why I'm shading this? Because this is the area I need to compute. This area need to be computed, right? So what I need to find? I need to find the probability of z is greater than or equal to -1.00. That's the probability I need to compute. That's actually the problem. But what I'm going to do, I'm going to take z value. Let me take a z value here. My z value is equal to -1.00, and I'm going to go to the table. And when I go to the table always give me the cumulative area from the left all the way to the boundary. When I use the table will give me the area of the region 1. That's very important you understand. The table always give you the cumulative area from the left side. So let me go to the table and let's see what we have. So we are in this table and look at this z-score. This is a -1. This is a z-score of -1, and look at the top, this is a 0, right? At the intersection of these two values, very simple, here and here, this is the value I'm interested in, 0.1587. So this is the area I got, 0.1587. So the z, we have -1, and the area or the probability, which is the same as probability, that comes out to be 0.1587. But remember, this is not the area we're looking for. This is this area. It's very important that you understand this idea. This is this area. 0.1587 is the area to the left of it. But we are interested in area on its right side. So what we are going to do, the area on the right side is equal to the 1 minus the area on the left side. Why? Because the total area is 1. This total area is 1. If I know the area on the left side, I can calculate the area on the right side but subtracting from the 1. So area on right is always equal to 1 minus area on left. And this is equal to 1 minus 0.1587. So this comes out to be 0.8413. And I can convert this into a percentage. This is equal to 84.13%. So that's the required area or the probability. So how you're going to interpret this? You're going to interpret this in this way. If I randomly select an adult, there is an 84.13% chance that his or her bone mineral density reading will be above -1. And in this way, this person will be considered in the normal range. He will not be having that particular disease. Now let's solve this problem by using Microsoft Excel. So we are in Microsoft Excel, and let's see how we're going to solve the same problem by using Excel. So we go to the formulas, go to the more function, statistical, and we try to locate the formula called norm.s.dist, norm.s.dist, this one. And now he's asking what is the z-score? It's a -1. And now he is asking, are you looking for the cumulative area from the left side? You will say, yes, I'm looking for the cumulative area from all the way from the left side. So this is the value you get, 0.1587, right? Let me show you how I get this one, just for you guys, for the reminder, how I get this formula. Just I'm showing you how I get this formula. Worked like this one, norm.s.dist -1 comma true. Right? But remember, this 0.1587 is the area to the left side, and this is not the area we're looking for. This is the red area. This is this area, and this is not the area we're looking for. Look at that. We are looking for this area, which is on the right side. And here is the formula. Area on the right is equal to 1 minus the area on the left. This is exactly what I'm going to do in Excel now. So let's go back to the Excel. Here I am, and now what I'm going to do, I'm going to do 1, apply a formula, 1 minus this value, the area on the left side. Let's do that. And the value comes out to be 0.8413. This is the same answer we get by hand computation. I hope you understand that. Let us see another technology, how it can help us, StatCrunch. So you go to the stat, you go to the calculators, and you go to the normal. Here is the normal. Now you have to fill up these things, and then you hit compute. It will give you the formula. The mean is 0, that's okay. The standard deviation is 1, that's okay. We are looking for the probability when x is or z is greater than or equal to -1. So this has to be changed to a greater than, and this has to be changed to a -1. So the probability, I told you the x value, if we have a standard normal curve, the x value coincides with the z value. X is the same as z. So you will read this, a probability of z is greater than or equal to -1. And when I hit compute, the value will come here. This is equal to 0.8413. This is the same answer, 4 decimal places. And look at that, how StatCrunch also display a picture for you for clarity purposes. Clearly, you know this is the area we were interested in. I hope you understand that. So let's see the last example in this video. Using the same bone density test, find the probability that a randomly selected person whose bone mineral density reading is between -1 and -2.50. And recall, And remember that if this is the bone mineral density reading comes out to be, it means there is a presence of osteoporosis. It means this person is having this disease if your bone mineral density come in this range. Okay, so how we are going to deal with this problem? Same thing. We are going to deal it by step-by-step method. The first step is to draw a bell-shaped curve. Let's draw a bell-shaped curve. Here is the bell-shaped curve I'm trying to draw. Exactly in the middle, write the mean value, which is a 0, and the standard deviation, which is 1. We have a 1, we have a 2, we have a 3, we have a -1, we have a -2, and we have a -3. Now once we have made this picture, the bell-shaped curve, and indicated the mean and the standard deviation, the next step is locate the value of your interest. Now note that in this situation we don't have a single value, rather we have two values. Look at that. So what we are going to do now, I'm going to locate these two values one by one. The first value is a -1. This is the -1. And the second value is somewhere here, -2.5. So let me draw a boundary wall for the first one, this one, and let me draw the boundary wall for the second one. Let me show you this is -2.50. This the value, this and this. And what the area we have to compute? We have to compute this area. This green area needs to be computed. This is very important that you understand that this is the area that needs to be computed. This is the area. So what we are interested in this situation, we have to find the probability that the z value lie between the two values. And what are those two values? The first one is -2.5 and the second one is a -1. This is the probability that needs to be computed, that needs to be calculated. Right? What I'm going to do now, please pay attention on that. What I'm going to do, first I'm going to calculate the area to the left of -1. Pay attention, this is very important you understand that. First I'm going to find the area to the left of a -1. Then I'm going to find the area to the left of -2.5, here, this area. And then I will subtract from the larger area the smaller area, and in this way I will get this green area. This is very important that you understand that how I'm going to do that. I will leave it the exercise for you people. I will only show you the computation by using Microsoft Excel or maybe by using a StatCrunch. Okay, so I repeat, first you're going to find the area to the left of a -1, and then you're going to find the area to the left of -2.5, and then you're going to subtract from the larger area the smaller area. You will get the middle area. Okay, so let's see how we're going to do that in StatCrunch. So we are in StatCrunch, and how we're going to solve this, we go to the stats, and we go to the calculators, and we're going to go to the normal. Okay, now in this situation we have to select, there are two options here, normal, calculator, standard, or a between. Now in this situation we are looking the area between the two z-scores, right? So we have the same mean is 0 and a standard deviation of 1, but we are looking for the area between the two z-score. The first z-score is -2.5 and the second z-score is -1, and I'm going to hit compute and you will see the value will show up. Here it is. So the area comes out to be 0.1544 or 0.1545. That's the area. Look at this one. This is the red area. This is the red area. This is the left of the -1, and subtracted to the left of the area of -2.5, and this is the area we are getting. So you can do the same computation by using Microsoft Excel, or you can do the same computation by using the hand computation, but I have shown you how you can do that by using StatCrunch just to save some time. Thanks for watching. So we are in Excel now, just to show you the same calculation. Look at that. The answer comes out to be 0.1524. This gives you the area to the left of -1, and this gives you the area to the left of -2.50. And when you subtract these two area, you get this in the middle area shown here. So I hope you can do this in Excel also. Thanks for watching.